Okay, this is 7.4b is in Bravo, and A equals this. This is matrix A, and they're asking us to find the inverse. Okay, so again, the way you find the inverse, get rid of that sign. You draw your augment sign, and then you put the identity matrix here. So because this is a 3 by 3, it's going to look like that. So again, what we're doing is we're making this look like this. So we don't care what this side looks like, as long as this side is 1, 0, 0, 0, 1, 0, 0, 0, 1. And then this then will be our inverse. So to get us started, what I would do is I would switch these rows around. So you're going to have 1, 0, negative 1. Oh, that's kind of a big negative 1. Let's make it a little smaller. And a negative 2, 1, 2, and a 4, negative 2, negative 3. Okay, what happens to this side when you start switching things around? Well, that changes too. So when you move rows around, you have to take the entire row with it. So we took this entire row and moved it up, and took this entire row and moved it down. So now we have a 1 there and we have a 0 there. Cool. So there's two things we have that are taken care of at once. We also have a 1 there. So these are very nice that one little move put all of those numbers in their correct places. So that's good. All right, next step. Next step is we want to get this to be a 0. So if we multiply this whole thing by a positive 2, then 2 plus negative 2 will give me a 0 there. So let's multiply this whole thing by 2, and we get 2, 0, negative 2, 0, 2, 0. And then we get our negative 2, 1, 2, 1, 0, 0. And let's go ahead, let's just not put all this junk right here because we're just adding this. This is not really part of the matrix itself. Okay, so that ends up being my second row. So my first row, let's write that again. My first row is, do it in black, 1, 0, negative 1, 0, 1, 0. My new second row is 0, 1, 0, 1, 2, 0. And my third row, which we've done nothing to, is, let's say, 0, whoops, red here, 0, 0, 1. Okay, now notice then that my second row is locked, and my first row is pretty well done. The only thing that I'm going to have to do on my first row is change that to a 0, and we'll get to that in a minute. But let's look at this. Let's work on this row here. If we multiply this whole top row by negative 4, when I add it to the second row, this will turn into a 0. So let's go ahead, and this is negative 4, 0, 4, 0, negative 4, 0, and we're adding 4, this third row there, 0, 0, 1. So it gives me a 0, negative 2, a 1, a 0, a negative 4, and a 1. Okay, so that's my new last row. So let's rewrite the whole matrix here, if I can get everything where it should be. 1, 0, negative 1, 0, 1, 0, 0, 1, 0, 1, 2, 0. And again, I like to show that that's locked. And then my last row is going to be this one right here. 0, negative 2, 1, 0, negative 4, 1. Okay, So there is where I'm at this point. Okay, so let's say I want to change this to a 0. Well, I have a 1 there, so if I multiply that second row by 2, let me make this a little bit smaller here so I have a little more room here. Okay, so I'm going to take and make my 2, oops, sorry about that, 2 times 0 is definitely 0, 0, 2, 4, 0, and I'm going to add this to it. And that gives me my new third row. Alright, so again I'm going to write what I have. And like I've explained before, I like writing this over and over again. It just keeps everything safe for me. Okay, and that my third row is this. Okay, now I have my second row locked and my third row locked. Now all I have to do is work on my first row and I'm done. And what do I need? I need this to be a 0. So if I just add my third row to this row, that will take care of that. Okay, so let me write this as my first row and my third row. 1, 0, 0, 2, 1, 1. This is my new first row. My second row, which I have locked, so I know it's all correct. My third row is locked, so I know it's all correct. And at this point I have completed, because I have my identity matrix, over here, and I have my new stuff over here. So this, as far as an answer goes, you would write a to the negative 1 equals that for an answer. Okay, so that would be the inverse of a. So my a, what is the very beginning, negative 2, 1, 2, 1, 0, negative 1, 4, negative 2, negative 3. Notice there is no kind of pattern here that you can go, oh yeah, I can see that those are the inverses. Now you really can't tell just from that. So that's the tough thing about matrices, is you really can't look at like numbers and say, oh, well, that's the inverse, just off the top of your head. All right, so let's continue on. Inverses with technology gives you a chance to use your graphing calculator or a spreadsheet like Excel. And now we're going to look at, does the inverse exist? Okay, because not all matrices have inverses. So they give us one in the example number 4, and they say we have a equals 1, 2, negative 2, 2, 0, 2, 6, 4, 0. And they want to know if the matrix exists. Well, if we get rid of this right here, and we put our line there, and we write our identity matrix, and we either use our calculator or we do it the old-fashioned way with pencil and paper, we get at the end, and I'm not going to do this one, but we get at the end, we're plugging along and not really done yet because we haven't flipped all of our stuff around, but you know, we're starting to get a good push here of getting things moved around, and we end up with as we're going, our bottom row is zeros on the left side. Okay, and one of the things I mentioned earlier in the first video is if the left of the augment symbol there, if it's all zeros, then the matrix A does not have an inverse. Okay, that's how you tell. You don't do anything with it, you just say, sorry, doesn't work. All right, so the next section is on encoding and decoding messages. And I'm going to skip this part simply because it's kind of a fun thing to go to find out how they come up with encryptions and encoding on the internet, etc. But we're not going to go over this. It's kind of long and drawn out, and I would rather jump into matrix equations since we're not going to do any of the decoding messages in your homework, but it's kind of fun to look at. So I will start with matrix equations on page 555 on the video 7.4c.